Well, kia ora, good afternoon, everyone. Welcome to Orchestrating Awesome, your unfair co-pilot advantage. Patrick and I are going to share with you a secret. Well, it's not a secret because our boss talked about it earlier, but the secret to making your co-pilot so powerful, everybody who doesn't have it has an unfair, you have an unfair advantage over everybody who doesn't have it. This should almost be illegal, but I'm really excited by what we have to show you today. It's always tough to follow Mark, so I'm going to try to bring it, but Mark's a tough act to follow. But let's go ahead and kick into it. All right, before we start, how do we get the music that we love? Not that weirdo. But, you know, people like the Beatles, Green Day, Drake, Taylor Swift, Alicia Keys, Ginger Ninja. We'll play. How do we get the music we love? Now, you're probably sitting there thinking, what a ridiculous question to ask me, Nathan. The music we love is created by the people on the screen behind you. They created it, they wrote it, they performed it. I paid hundreds of dollars to see them at Eden Park last year. I can check Mark's second brain for the receipt. But there's actually something going on behind the scenes to bring the music we love to life. Let's talk about that. So we've got to travel back in time to the 1980s. Oh, wow. Probably before many of you were born, and I feel really weird saying that now. But back in the 1980s, Lionel Richie got together dozens of the most popular recording artists of their time in a single studio on a single night to record a song that became iconic to relieve famine in Africa. Maybe you've seen the documentary on Netflix, The Greatest Night in Pop.
Yeah, awesome.
Despite the incredible amount of talent that was in that studio that night, and probably the egos to go along with it, every single one of those artists would have attributed the success of that song to one man. Bet you don't know who that is.
Oh,
Quincy Jones
yeah.
is a producer. He's kind of a big deal. He has worked with some of the most iconic artists of the last several decades. Jackson, Aretha Franklin, Stevie Wonder. Could go on, but we're short on time. But the producer works behind the scenes, create the music. Now, what's interesting is he is one of the most influential people in the world of music, and yet you have never bought an album with his picture on the front, never paid hundreds of dollars to see him at Eden Park, and yet he has influenced the soundtrack of your life more than you can possibly imagine. See, producers make music awesome. They work behind the scenes and they bring stuff together. They coordinate musicians, vocalists, video engineers. Bringing these elements together, adding effects, drum beats, whatever, to make the song into the finished product. Here, love. What they do, they bring the right things together, time, just the right way to create something awesome. But I want you to keep that idea in the back of your mind. We're going through our session today. Hello, everyone. I'm Nathan Rose. I'm a solution architect at Olympic 33 here in beautiful Auckland. Also a Microsoft MVP in business applications. Myers, who's an MVP in the States, always says, how do you know someone's an MVP? Don't worry, they'll tell you. If Guilty. And my mission is to unleash human creativity via the Power Platform and low code. Low code is my love language, which means today's going to be a bit off brand for me because we're going to dive deep into the world of pro code. So this is kind of uncomfortable territory for me. We're going to show you how pro code and low code working together create something incredible. I'm also joined by my colleague, Patrick Pickworth. Patrick created the demo you're going to see this afternoon.
Cool.
He is one of our most talented software engineers, and no, he's not looking for a job. You can't have him. Freakishly good with semantic kernel, as you're going to see. And he never met an LLM he couldn't tame. And so Patrick's going to be driving the demo in a little bit. Let's get into it. So, an overview of our time. We're going to start out by looking at what semantic kernel is. Martin explained the broad strokes this morning. We'll do a bit more of a deep dive. By the end of this session, you should have a good understanding of what it is and how it works. We'll explore how it makes your copilots awesome. This is the low code, pro code coming together. Talk about why you'd ever want to swap LLMs in the first place. Patrick's going to show you semantic kernel in action. I'm still trying to locate the lower part of my jaw since I saw this last week. It's pretty cool. And we'll wrap up with some Q&A. Now, Q&A is my favorite part. I get my best ideas and best content from the questions that you all ask. So I really look forward to your questions. And if you're old enough to get that reference, you might be applying for NZBAS24 soon like me. All right, all seriousness aside, what is semantic kernel? Well, it is the lightweight open source SDK made for the world of AI. Think of it like middleware. It makes LLMs and APIs plug and play with your code. It means you can select the best LLM for the task at hand. It gives you some key advantages. It unifies low and pro code. And your copilots are now endlessly extensible. Semantic kernel is the awesome inside your AI applications. Okay, but how does it work? This is a screenshot I grabbed from the Microsoft docs of the architecture of semantic kernel. Let's break it down. Let's make this a little more digestible. At the middle, you've got the semantic kernel SDK. At the top, your code. So in the demo we're going to show you, we've got an measure function running in C#. It's open source, so you can use Python, C#, and there's another one. So it can work with different languages. On the left here, the plugins. This is your business logic. Cloud flows, my personal favorite, low-code plugins. Watch this space. This stuff. Hooks and filters. This is where you can give instructions to your plugins and control their behavior before or after they fire. And of course, the brains of the operation, large language model. This is the architecture of semantic kernel. Okay. Let's go another level deeper. How does it actually work? This is a screenshot, again, from the Microsoft docs, showing how semantic kernel works. It's a little confusing, so let's break this down. So to start, make a request, kind of like you do now in Copilot. Put a prompt into the Copilot, the app that you're working. What happens next? Semantic kernel serializes the functions. What that means in plain English is it says, here's a list of everything the programmers taught me how to do. So when your pro coder is working with semantic kernel, they're going to write functions. And so when it's called, it's going to say, I can do all of these things. Next thing it's going to do, it's going to send a message to the LLM. It's going to send your prompt and all the functions. So here's what I've been asked, and here's everything I know how to do, and that's going to go to the large language model. Now the cool part comes. Model determines which functions to run. Let's say we send 3 functions to the large language model. Based on the prompt, we only need number 1 and number 3. It's going to say, okay, I need to run number 1 and number 3. And the even cooler part, the order to run them in. What if I need to run number 3 before number 1 based on the prompt? And so that's the smart stuff going on. Once it's done that, it's time to do stuff. Apply to the user, invoke functions, then and repeat. That's how semantic kernel works. But we're still kind of high level. Let's bring this down into our world, the stuff we know and love and understand. This is a badly drawn architectural diagram of the demo that we're going to show you. Mish got me into mural years ago, and I just haven't kicked the habit. There's better tools, but as you can see, my skills aren't great. Anywho, moving on. So at the center here, we've got our semantic kernel, the Azure function in C#. To the left, the large language models, and to the right, all the stuff that we know and love: Power Automate, Dataverse, Copilot Studio, Dynamics 365 Sales. So semantic kernel acts to unify low-code elements with pro-code elements to create amazing things. All right, but let's get even more specific. Go through the actual process. Let me show you what Patrick is going to demo to you in a bit. All right, so we have a user in Dynamics 365 Sales. I probably should have put Patrick's picture there, but anyways, I thought I was doing the demo at the time. So they're going to be using a Copilot. I'm going to enter a prompt in the Copilot. And that's going to call a Cloudflow Power Automate to call the Azure function. Now, in the ideal world, we'd use a custom connector. But in Copilot Studio at the moment, you get a red. You can't do this when you try to add custom connectors to your actions. So it's a fast-moving space. My guess is this will be available sometime soon. But for the time being, Power Automate is a perfectly good workaround. Okay, so we call our Azure function. Now it's time to talk to the kernel. Semantic kernel is going to receive our prompt from Copilot. It's going to list out all the things that Patrick taught it how to do. And we're going to go to an AI to figure out which functions we need to run and the order to run them in. You might be thinking, OpenAI is what runs Copilot. This seems like a lot of rigmarole to see the same thing. We'll get to that later. But we're using OpenAI's LLM, and it's going to return the functions in the order to run them in the kernel. And the first function that runs is going to query Dataverse and get a list of products. Back to the kernel. Then we just need to get back to the user and chat. Here's the list of products. Next, the user can create a quote from them. So Copilot will say, do you want to build a quote? The user will say yes. There's a message back to the kernel. It's going to start calling business logic. And we did this in Power Automate because I insisted that it be as low code as possible. You could use Azure Functions. There's lots of different ways to do this depending on your scenarios. We used Power Automate. Power Automate is going to go and create the opportunity and the quote for you and return the URL to it in chat so you can click it open. So that's what we're going to show you. All right. What's going on behind the scenes? This is a screenshot of Patrick's code. So at the top, all the things I know how to do, and the prompt and all the things I know how to do to the LLM, return result back to the user. Going on behind the scenes. All right. Why did we use OpenAI? Actually, I hope to use Mistral. I don't know about you, I'm a little OpenAI'd out. Perfectly good, but you know. Anyways, we wanted to use Mistral, but it wasn't cooperating. It struggles with things like chained functions. Turns out you do get what you pay for in the LLM world. So we wanted to have a working demo. We swapped Mistral for OpenAI. Here's the cool part. Ready? It's going to blow your minds. Seconds. Not hours, not weeks of rewriting and refactoring code. Patrick switched LLMs in seconds. Endpoint, model, API key, boom, done. How easy it is to make LLMs plug and play in semantic kernel. Okay, but why would we want to switch the LLM? I mean, there's a reason Microsoft chose OpenAI to power all the copilots, right? It's the best. Why would you want anything but the best? Well, to think about LLMs kind of along the same lines as the project management triangle. We swap out large language model for a project. LLMs can be expensive or cheap, or bad, fast or slow. So what does that mean in terms of our demo? Well, a number of years ago, my good friend Meatloaf once said, you can have LLM that's good and fast, but it's expensive. You can have one that's fast and cheap. Sucks. Or you can have one that's good and cheap, but it's slow. Okay, but why would we want a not so great LLM? I mean, don't we want the best? The reason OpenAI's LLMs are so great is they've been designed to pretty much be asked anything. We've all used ChatGPT, and you can pretty much ask it anything you want, and you're probably going to get a cogent answer. It's been designed to do that. That's why it costs what it does. That's why Microsoft uses it in their products, because they have to be prepared to take any kind of input and render an answer. But you pay for that kind of quality. And if you were designing a customer portal, you would definitely want to have that kind of quality interacting with your customers. What about a line of business application? You've got somebody in a warehouse. All they need to do is query invoices or quotes or something like that. It needs to be fast. Do we need the best LLM in the world for that? If we can train the user to use a good prompt, we can get away with fast and cheap. Save ourselves money. That's a reason why you might want to switch LLMs. Okay, this brings us to our demo.
Good question. Is that one of the reasons why it's more beneficial to use the kernel as opposed to Azure OpenAI?
Use what, sorry?
Is that one of the reasons why it's more beneficial to use the kernel as opposed to Azure AI?
Yep, so Azure AI locks you into the OpenAI models. Semantic kernel lets you work with the thousands of LLMs that are out there.
That's the biggest benefits.
So you can add LLMs, APIs very easily to go and do stuff.
Is there like a directory of all LLMs and what their primary purposes are?
Probably.
And which two of the three?
Why don't you just ask Copilot next time you use it?
Yeah, I'm sure there is. We can get one for you. So what Patrick is going to show you is we created a quote in Dynamics with the kernel. We're going to go behind the scenes in the Power Platform and semantic kernel, show you how this all works. So Patrick, I'm going to pop out of the here and There you go.
Fantastic. Hi, everyone. I'm Patrick. I'm a long-time pro coder and first-time low coder enjoyer. It's nice to meet you all. All right, cool. Yeah, cool. So I'm just going to jump right into it. We've got our Copilot Studio that we have open here. A really quick question though: has anyone won Lotto recently and decided to buy a really expensive coffee machine? No, me neither. But for this
If
demo,
you take the 90-day mentoring challenge, you might.
yeah, for this demo, I'm going to pretend I did. Just going to pull up little things I wrote here. I'm going to talk through our chatbot that we have configured here. So I'm going to say, yeah, rich barista looking the machines.
Remember, if you have to ask the price, you can't afford it.
Them no upfront. So fantastic. Our Copilot's going to go ahead and do a bit of thinking, go, interesting. Those two things usually don't go together. And if all goes well, we're going to get a reply pretty darn quick. Going, our
Takes
product.
a second with semantic kernel. There we go.
There we go. So what we have here is we have a bit of chat from our chatbot that's going, well, with this rich, maybe you want to have a look at some of our expensive coffee machines that we have. So they're listed here with their name, a bit of a description and a price, and we can kind of scroll down this list and see what might be suitable for us. I might go ahead and say, you know, something like, well, picking some coffee that take upwards of 100 fees. I am a fiend for coffees.
Okay.
Yeah, lightweight. We'll see how we go. So it's going to go ahead and do a bit more thinking for us. Takes a bit of time. Maybe it needs some of these coffees I've given it.
Toso is a really expensive brand, let me tell you. So
There we go. So it's come back and said, okay, well, based on this, it thinks this is probably some coffee machines that might be suitable for us. So we can go down this list here and, you know, the last one sounds really expensive coffee with all my money. Would like just cafe S100 semi-automatic.
last bit sounded kind of American to me.
Yeah, cool. Semi-automatic is available for the purchase price of too much money for me right now, realistically. But would I like to proceed? Please give me a quote.
There and go, are there any discounts available?
You could. It might come back and say I'm cheeky. Fortunately, I didn't program it to be so generous, but it has in fact. come back.
Too. Okay, so it's gone and generated a quote for us.
Go ahead and click the view quote link. This is going to, if I've done this correctly, and I have, it's brought up Dynamics 365 with a quote. It's a little bit hard to see. I'll try zoom out just a little bit here, where you'll be able to see this is a cafe semi-automatic for an eye-watering nearly 20 grand.
Prompt to quote.
But we have a quote. Okay, cool. That's really nice, but won Lotto recently, so maybe I want a more complicated scenario where, you know, I'm looking for even more coffee machines. I please a couple yes. Automatic coffee machines. And got sell and about 4 pots.
Forgiving is it?
In terms of
Like if I just said
mistakes or
S100 semi rather than semi-automatic.
Right.
it should still be able to get it.
It is learning. So this morning when it said, do you want to proceed, yes or no? I said proceed and it didn't work and now it does. So it's getting smarter.
Fantastic. So it's actually come back and said, cool, you've got 2 units at $17,900 each for the semi-automatics. We've got an AirPod XL and we've got 4 of the AirPods, and we should be able to go ahead and finalize this quote here, opening up Dynamics once again. Should be loading in.
Fresh.
The same code or
What's that?
the same code?
Same code.
Same
What?
code.
Oh, it's generated a new quote in this.
No, it's generated a new quote.
But as we have here, we've got 4 AirPods, an AirPod XL, and a couple of those Cafe S100s.
Julia.
It's different, yeah, for first one,
I did it.
first item.
Quote
That's the difference.
an existing chat.
Because that's the way we
It's
built
just the way we've coded it. Yeah. A low code newbie, unfortunately. Sorry.
in production, you would probably do it a little bit differently, but this is, as Martin talked about this morning, thin slices. So much version 1. Craig, you had a
I was
question?
just gonna say, could you also say that you're part of the company that are filling the position?
Yeah, we were planning to build that and then we both got busy, that pesky billable customer work. And, so, but yeah, we were planning to demo that today.
Absolutely.
It also has an opportunity.
So
It has an opportunity.
you're going to see that shortly.
Absolutely. So if we jump back here, what I think would be cool is probably showing how the magic's happening behind the scenes. Yeah.
Let's lift the veil.
All right, cool. So scrolling down here, we do have knowledge that we were attempting to add to it. I'm giving it a go. It's currently disabled. All the knowledge is coming from a function app and our other LLM. To try and use the accounts and product price list as we're trying to marry this up to say, I'm from, Contoso Coffee, I would like my discount. That didn't quite work for us. So we went ahead and just did it the pro code way. But below here, as Nathan alluded to, we've got some Power Automate flows. So I'm going to just jump into this one here. Effectively here, I'm just giving it a little bit of a description on what it can do for this action. So I would like it to pass information to this agent regarding the products to create a quote. This agent will then create a quote when asking for coffee machines or how many coffees a machine can make. Call this function to return information about the coffee machine products. So it's going to go ahead and do that. What I'll do is just jump across to Power Automate here and just show you what we actually have behind the scenes. This one here is effectively small in terms of what it actually does. It runs the flow from Copilot. Was an HTTP endpoint, which is actually just our Azure function behind the scenes. And then it will take the response from our HTTP endpoint and return that as a response in Copilot. And Copilot will massage that response into something that is easier for the customer or the end user to read and understand.
This is our workaround because custom connectors aren't hooked up in Copilot Studio yet. So
Fantastic.
Monica.
I might be sleeping earlier. Is it the customer experience or it is a user experience? Like in the sense, like, is it outside to the board? Any customer can come? Or is it like an
You could
individual?
do it either way. So when we initially thought about it, the idea was you have salespeople doing massive quotes and they need to add a lot of products. You could have it on the front page of a website. So at this point, again, thin slices, we wanted to just be able to do it and then you can even think about, go to.
So absolutely right. The other flow we have, I'm just going to jump across to it. That's a bit more meat and potatoes. So while we're actually seeing here, this blew my mind. I was preparing to write this all in code stuff, but Nathan came along and said there's a way easier way.
Jordan.
Yeah, he has converted me. So basically, this is how we're behind the scenes at generating our quotes. We have an HTTP endpoint that our Azure function can call, basically as the trigger. So behind the scenes, I'll show you some actual code in a little bit. But basically, a function will say, hey, Power Automate this thing for me, and it will pass some information about the products and maybe the customer in the future as well. We've just given it a template to pass what it gets as part of the HTTP request into something that we can then use for Dynamics 365 to first create a new opportunity and iterate through the list of products that we presented it, and then to generate a quote, simply to return the quote ID that we pass with the URL as well. And that's how when it goes all the way back up to Copilot, you say, here's the link, you can go ahead and click that.
Quote's just an action in Dataverse, so it's just an unbound action.
Fantastic. So that's the kind of low code behind the scenes. I'm going to quickly just jump across to the actual code I wrote. Please be a little bit forgiving. I wrote this pretty quick after coming back from vacation, so it does work, but it could look better. Let me just go ahead and fantastic. So really cool part of this is this file here, CAI CS. The name of it is really irrelevant, but that's what it is. Cool. So effectively here, as Nathan alluded to, realistically, when you want to change your models that you supply, it's really a two-liner change. I've just wrote it out that we've got Azure OpenAI connected. And then down here, we've got Mistral. As Nathan also was alluding to, the reason we switched from using Mistral initially to Azure OpenAI is at least the model that we deployed had a bit of trouble function chaining, which is to say, if I ask it, generate me a quote, I first want the agent to fetch the products from Dataverse, so we actually know what we're building a quote off, and then to actually generate the quote afterwards. Mistral, it would get as far as going, oh, I've got the products, and then I'm going to hallucinate and say, here's your quote with no link and not running any actions. So many hours bang my head against my desk, but one keyboard later, we've got this. And it works fantastically. Basically giving you a really quick anatomy of what's actually going on here. This is deployed as an Azure function. As was said before, what we do is just set up a kernel builder, and we say kernel builder.add Azure OpenAI chat completion along with our model and all the security there. So then we define what's called plugins, which you saw in one of Nathan's diagrams before. And that's the really cool part of this, I would say. I'm just going to scroll down here. This part is a little bit interesting as well. We've defined what's called a chat history. This is where I can instruct the AI to say, you are an assistant. This is what you can do. Retrieve products, generate quotes, and inform the user politely if you run into an error.
So you create the boundaries.
Yes, exactly. Yeah, you can't. I think about it like doesn't know much better, so you have to be a little bit specific with it. But yeah, absolutely. And the other liner that you would need to change in this particular case here is just some of the execution parameters. So the semantic kernel that we deploy knows that in this case here, it can automatically invoke these functions that we provided. I needed to be a little bit explicit about this and just trying lots of things and hoping everything would work. In this case here, the reason it's separated into two is there is very slightly different naming conventions for the tool calling behavior. In this case here, it's Mistral AI tool calling behavior. But Azure OpenAI's, it's just tool call behavior. Another note about Mistral implementation is that this is still a bit experimental and definitely subject to change. We may find in future that this is all unified. If that's the case, it will go from two lines to one line of code changes, and hopefully in future after that, just be in terms of changing a variable. What I'm really hoping to get to.
The other thing to point out is that OpenAI is the only GA semantic kernel LLM. The other ones are still under preview.
Yeah, don't let that stop you from exploring this. There's just some really cool stuff.
UAT.
Yeah. Yeah. So
just maybe explain to the non-coders the double, triple lines.
Oh, sure. I've called this one line, but yep, as you've fairly pointed out, we've got maybe 4 or 5 lines here. Effectively, what this is just a container that's called Mistral AI execution settings. And then the other one below here is Azure's OpenAI prompt execution settings. So my hope and our probability in future will be we will have something that is probably just called something like prompt execution settings, something a bit more generic that will mean.
I was saying that the actual lines mean that that's not code, it's just for text.
Oh, sorry, this is all code here.
Yeah.
Sorry, do you mean these green lines that
Yeah.
you see here? This means it's commented out, so this is just text, yes. Yeah. So basically telling the program, don't execute this, this is just decoration, basically. Cool. So just scrolling down a little bit, we actually have the demo plugin, which is the really exciting part, I think. This is where we define what we call our kernel functions. We've given them action names and a description. So you can see with this one up here, I took a lot more care telling it maybe a little bit more explicitly what it is and what it can do. And the other one I thought, you're a pretty expensive LLM, you should probably be able to figure it out. And lo and behold, it can. So it's been good. What you may notice with our action names down here is they're all lowercase with the underscore between the words. There was just a real small footnote I found in Microsoft documentation that was saying a lot of these LLMs are mostly trained on Python code and for coding abilities. So it's worth just specifying an action name with a Python style method name. It's definitely helped, I found. But yeah, cool. Everything else down here, this is just a real codey heavy way of us connecting to Dynamics 365 to go retrieve our products. This part's not really the exciting part, unfortunately. Well, at least for me. The way Nathan showed me, it was very exciting. But we basically just have some query parameters here, which basically filter out a whole bunch of information that we don't need. The aim of the game is to provide the least information possible to get your same result. Will result in that it's more performant call. LLM doesn't need to sort through so much more information to get you the result you're actually after. Just try to filter that down into the key things we actually need.
So that's why there was no images on the coffee machines.
But yeah, fantastic. And surprisingly, these are the only 2 functions I actually implemented for this demo.
Cool. Anything else, Patrick? Or
Just I hope you guys have a great rest of today. It's a lot of fun. And, yeah, nice to
give
meet you.
Patrick a hand.
First time.
Patrick's first time. You did a great job, eh? All right, let's all right. So we've seen semantic kernel in action, seen it generate a quote in Dynamics based on prompts. So that brings us to the end of the demo. So we've seen semantic kernel, we've learned all about it, how it makes your copilots awesome by letting you make APIs and LLMs plug and play, how it orders the functions and includes them with the prompt so that you can get eligible answers to your questions and do some really cool stuff. Seeing how it acts as the producer for your copilot, bringing the right things together in the right time in just the right way to give you what you want. And how it bridges the pro and low code divide.
The feeling is there's a however.
Good.
The feeling is there's a however.
Nope. And why you might use different large language models depending on the task at hand. So that brings us to the end of our time together. Thank you all so much. absolutely love coming and showing these kinds of things. And we're happy to take some questions.
This is totally not my area, so
Me
I'm
too.
not even sure how to word the question, but the producer analogy is helping me. So like you said, the producer is the guy that like puts things together in the right way.
Yep.
And you said that the chaining of functions was a problem with the Mistral LLM, but not with the
AI one.
OpenAI one. So who is it that's actually determining the order and piecing together the functions? Is it the semantic kernel or is it the LLM?
The LLM, wouldn't it?
Yes, it's the LLM that determines it can call one function or it can call multiple function. It's in knowing that the next step is to call the next function.
So what do you do in terms of coding to help it to do that? Or do you just hope it figures it out?
That's a really great question. Through trying to use Mistral, I gave it lots of things. Like in the description, I said the next step after you get the products is you should probably try and generate a quote. I've tried giving it many instructions and nothing seemed to work. It may have been a case of the model size that we deployed for Mistral. We deployed a Mistral small, really trying to see how much we could get away with in terms of paying less but getting the exact same result. It could mostly reliably one function. In some cases, it would even hallucinate that and just make up some products about coffee machines as well. It just wasn't reliable enough. And it's still experimental for every plugin that's not OpenAI's connector at the moment. So I would presume probably in the next, sooner rather than later, we should see that being fully supported and probably function chaining supported for all models. It's really just the first step where the first function can get called and then after that it kind of falls over a little bit.
So you get the sense of how this can be really powerful in the world of agents where we're doing stuff autonomously, learning.
Do you have any like insights or lessons learned? Because it's quite new for like pro code and low code to work together, right? Rather than be rivals. So like if we're gonna go from here and do more of that, like what should we do?
That's a great question. I would say just do it. Just get hands-on with it, see what it can do, learn. Yeah, I mean, our probably our biggest learning was that Mistral doesn't chain functions too well, and that you get what you pay for in the LLM world. So yeah, Amelia.
So does it cost and how does the licensing work?
It's open source, so I'm guessing that you don't pay licensing for it. But yeah, we'd have to get back to you on that.
You gotta have the download.
Semantic kernel, it's just a package you can consume for at least your C# applications. That's all there ready to go. Their GitHub's fantastic as well for semantic kernel. You can actually see all the connectors that they currently have available. So yeah, it's not just Mistral, so many more. And this morning I saw there was a MySQL connector as well, so you can expand the knowledge it has.
The things like get products, would that have been okay to be a Power Automate as well? Is there a particular reason why, or was it just for the demo?
Well, I think that was the pro coder in me saying I should just be able to call these endpoints and retrieve these products, but you could just as easily do it with Power Automate and just make the pro code piece even more thin.
Another
So you didn't-
writing flows as good as Billy.
You didn't show us the actual trigger and response, but so is that how it knows how to interface with the flow?
Yes, so effectively from the point where we say get products, it will return a list of products from Dataverse with a whole bunch of additional information. I wrote a really small function that will just conform it to a really thin object, which has like your name, your price, and a quantity. The AI will then interpret whatever request you give it for the quote saying, I want like 3 of these things, a couple of those things. Will understand that those are quantities and should be associated with the object and do it itself and pass that through to the next Power Automate flow, which then will generate the quote for you.
You were saying earlier in the piece, one of the biggest benefits and kernel is being able to swap out LLMs.
Mhm.
However, in this demonstration, we are forced to use OpenAI is the standard LLM that Microsoft uses inside Azure AI. So I guess following this particular innovation, I don't finally see the tangible benefit of using Cassandra kernel over Azure AI as the kind of orchestrator. Do we have any indication or any other LLMs which can handle any idea of different cycle? Because in this demo, I'm forced to use what you're told in the demo.
Yeah, sure. No, that's fair.
Seconds.
Yeah, in a perfect world, we would have used something other than OpenAI. We were just time poor, so we wanted to have a working demo. But I would encourage you to go try it with lots of other LLMs and see how you go, because they do have their own strengths and weaknesses. And sometimes if you need something cheap and fast and you can get it to work, awesome. So